Hello everyone, welcome back to ptet.chemistry channel. So this is a new section on organic nitrogen chemistry. So there isn't a lot of it in air, so I'll finish this in one go in just one video. Or maybe I'll split it into two videos actually, 5 questions each, yeah? Okay, so this is just organic nitrogen chemistry. So they overlap a lot with the other functional group, as you will see. For example, in this first question here, we see that we are trying to produce nylon 66. Well, sorry, nylon 66 is the polymer. And the production of one of the monomer of this polymer from compound X. So here it's very important to get your carbon counting correct. So there's 1, 2, 3, 4, 5, 6. So there's 6 carbon there. And you know you can reduce that. So there's N triple bond C blah blah blah, there's C triple bond N. So when you do reduction, you gain it hydrogen. Well, it's not really using H2. I think you will learn more of this in A2 actually, which is why they are not asking you on this step. You use lithium aluminum hydride and you get NH2 and CH2 and blah blah blah, CH2 and NH2. Have a look there. Your nitrogen carbon triple bond has become CH2 NH2. Alright, so there's reduction there. The nitrogen gain hydrogen, the carbon gain hydrogen as well. But they're asking what could be X. What is the reason for using KCN in ethanol? That is your standard condition for nucleophilic substitution. You want to add carbon. You end up with 6 carbon, so you cannot have 6 carbon here, not 6 carbon, because if you started with 6 carbon and you add more carbon, how can you have 6 carbon? You must have lesser than 6 carbon, alright? 1, 2, 3, 4. Here you have alkene and alkene, but there is no alkene there at all. And this is nucleophilic substitution, not electrophilic addition. Okay, so B is out. Moreover, Cn minus is a nucleophile. Okay, it's a nucleophile, not an electrophile. Alkene is electron rich. This is electron rich. They don't go together. Yeah, electron rich and electron rich, they don't go together. This is alcohol. We're not using ROH to RCN. That doesn't work. Okay, we know that it's the halogenal alkane that is easily converted to RCN. So we are not even looking at that, and definitely we are not looking at that as well. Yeah, not using carboxylic acid to RCN. Of course, we can convert RCN to carboxylic acid by hydrolysis, but that is that way, hydrolysis. Whereas here is saying that this goes to this. Okay, it doesn't work that way. So in fact, you are left with A. This is 4 carbon. As you can imagine, you could replace the Br with a Cn, then you add 1 extra carbon. To replace this Br with another Cn, you add another extra carbon. 4 carbon plus 2 extra carbon, 6 carbon, where the terminal are Cn and Cn. Okay, of course this question could easily become, when you add HCl and reflux, what could it become? Okay, it could actually become option D, which is 1, 2, 3, 4, 5, 6 carbon. This N become carboxylic acid, this N become carboxylic acid. Okay, so different kind of chemistry, hydrolysis, and this is reduction, both of which are in your AS classification of reactions, and they can easily ask you, suggest or name the type of reaction in your theory paper. Okay. So I just realized that I should have a page break there so that it looks a lot cleaner. But anyway, now that I've started, I'll just continue this second question on organic nitrogen chemistry. It's not a big section anyway. So this is saying that when you have an ester, that is an ester by the way, but that is a ketone. Okay, so and this is a phenyl hydrazine. You will have heard of 2,4-dinitro phenyl hydrazine. So it's actually similar kind of chemistry, but except that when you have that, you will have NH2, there's your 1, there's your 2, you will have NO2, and you have another NO2 at position 4. This is your 2,4-DNPH that can react with ketone to give you an orange precipitate. but the ester will not react. Okay, so how would the ketone react? Well, first of all, the ester will not react. Here your ester has reacted, so we don't want the ester to react because only the ketone reacts with the hydrazine. Of course, this one is the one that give you the orange PPT because of the reaction that happened with ketone, for example. So this is the one that will attack that and give you that, and it's actually a condensation reaction. So it's actually two steps. The first step is this nucleophilic addition, which I just shown you. Okay, and then the second step is you involve elimination. So overall, there are two steps of the reaction, and what you will get as the orange PPT is basically this NH and carbon R and R dash, and you get H2O. Where does the H2O come from? The H2 and the O, the H2O. Okay, so this unusual product, even though they are not normally asked in A level, but know that this is an AS level question, and they could very easily ask you to write this out or write the balance equation. If you don't know how it looks like, you're going to be disadvantaged, and this is actually covered in your AS chemistry. Here, this is without the nitro group. It's going to do similar thing. Okay, so what's going to happen is I will have CH3, C, instead of the O, which I will lose, instead of the H2, which I will lose, I will connect this carbon and nitrogen together, which is what I've done there, connect the carbon and nitrogen together. This nitrogen will have lost the H2. Now I have NH. Okay, this thing here is just the phenyl ring, which is part of A2 chemistry. They don't do much in this sense, they just remain as such. And then I will have CH2 and then the rest of the ester. And again, I just want to emphasize that here you have reacted the ester again, and that one is automatically a no-no because you don't do anything on the ester. Alright, and what has happened here? So obviously the correct answer is D. As you could see, you get the carbon-nitrogen double bond. Of course, you kick out the H2O, the H2 from the NH2 here, the oxygen from the ketone here. Alright, the ester is not reacted. So here the ester is not reacted, but as you can see, you have a CH2 which is there. And where is your CH3? Your CH3 is gone, and somehow you have just bonded them together. This is not a condensation reaction that goes on when you have a nucleophile and a ketone like that. Yeah. Okay. So there is a wrong chemistry there for whatever is going on. All right. So moving on to the next question. So this is about the cyclic compound M. And I hope you can see there is an ester, and I'll use a different color. This is an amide. Again, amide and ester, both of them will cover in O level, and all you're doing at AS level is just revisit them. There's a reason why you need to master your O level before you could actually do your A level very well. Yeah. So when we do hydrolysis, this is acid hydrolysis. So that means we will not get a carboxylate. But bear in mind that we have an amine, which means that your amine will protonate. So if I draw the product, that is the alcohol, that is the carboxylic acid, that is the acid, this is the amine. But be careful, you are in acid. This is amine, which are basic. So what happened is, this will not be NH2, it will be NH3 plus, and you're in dilute HCl, so that means it's NH3 plus Cl minus. Your nitrogen do not form 5 covalent bond. Think about your 2s and your 2p orbital. Maximum 8 electrons only can be filled, alright? So it's actually ionic interaction there between the NH3 plus. Okay, well, it's actually nitrogen with 4 covalent bond. It's a tetrahedral nitrogen with 109 degree. Yeah? I can tell you the only sensible option there is that and that, which is the HO2C. Whoops, this is wrong. This is correct because have a look here. This is alcohol connected to the base, well, the protonated base is a carboxylic acid. This is a carboxylic acid. This is an alcohol. So that's how I was able to tell it's wrong. There's a plus on the nitrogen is connected to the carboxylic acid, and that is the correct one. In fact, that's the only correct one out of all of these. Very easy to make the choice, yeah? You don't get the aldehyde, obviously. All right? So this fourth question is again about hydrolysis, but this is now a base hydrolysis. Okay, so which of the bond 1 and 2 will be broken? Okay, so that is the amide. This is an amide bond, CONH. This is an ester bond. Okay, so both of them can be hydrolyzed by base hydrolysis. In fact, what you will get if you are in a basic condition, think about this. This is acid, so this will get deprotonated. This is basic, it will remain as such. You will get a carboxylic acid, but you're doing base hydrolysis. This will again be a deprotonated carboxylic acid. This will remain as basic. You will get a carboxylic acid again, so again you will get a salt because you are under basic condition. This will just be the normal alcohol. I talk a lot, but it's better if I show you what's going on. Of course, you should be able to do this on your own as well. They don't tell me what is the base. Okay, so I'm just gonna assume that it's a base. I don't want to put down the Na+, but if it is NaOH, it will be Na+. If it is KOH, it will be K+. But it's a salt because you are under basic condition, right? So that one is a CH2. The NH2 remains. Again, I get another salt there. There's the first product. The H2N, the C6H5, which was like the phenyl ring, which we saw from before. This is an O- again, because this is the carboxylic acid product. And then your third product is HOCH3. These kind of questions are very popular in theory paper, not just in AS, but also in A2. Okay, so it's not just about identifying what bonds are broken, but also be able to draw out the product and think about, are you under acidic hydrolysis or base hydrolysis, yeah? Okay, and you also have a mixture of basic and acidic group, so it really depends on, are you under acidic condition or are you under basic conditions? So obviously, both of these bonds are broken in the amide and ester hydrolysis using base, yeah? So this question 5 is asking another amide. So this is CH3CO NH H. So we have excess aqueous sodium hydroxide. So this is base hydrolysis. So you will not get the carboxylic acid. You will get the salt because you are under basic condition. And you will get the base because the base doesn't react with the base. But this is an inorganic product because it has no carbon. Okay, NH3 will be given off as a gas. It is a gas at room temperature and pressure. Aqueous ammonia is different from gaseous ammonia, which is the natural state at room temperature and pressure. It can of course dissolve in water to give you aqueous ammonia. Because of the strong hydrogen bond, it can form with water. Be very careful, yeah? So you don't form the ammonium salt because not in acid, all right? So this is a CH3, CO2 minus, Na plus. So it's got to be D. There you still have your amide, and there I don't know why you have a nitrile. It just doesn't make sense at all. So this is the end of this 5-question series on organic nitrogen chemistry. Please subscribe to the channel if you haven't, and please share the channel with your friends, your colleagues, and your students. And I'll see you in the next video.